All right. Good evening, everyone. I hope you're having a great day, whether you're at work, whether you're at school. Uh, we're getting to start our term, 8 weeks. Hopefully, everybody gets to enjoy it. Hopefully, everybody gets to learn something about it. Even though this is a beginning class for most of the majors, especially for the College of Business, my hope is that you view the class from the point of view of a professional person that is talking, directing, and working with peers, supervisors, potential employers. That is the goal when I'm giving you the information and when we're working with all the data and information that we'll be able to see. It's 8 weeks. On a normal circumstance, this class is 4 hours a night, once a week. We get to have 8 weeks at 2 hours a night tops. So that means that many of you are going to, all of you are going to be responsible for working on a lot of the material by yourselves. I will always be available for you to work on any questions you have. I'm pretty flexible. Even though I work full time during the day, I will be able to respond to you. As some of you already did, when you text me, please let me know who you are. That way I know to be able to respond to you right away. If you call me, leave me a message. I usually don't answer the telephone if I'm at work unless you leave a message, and then I will be able to respond to you. All right. Who are we? As you probably have seen my Canvas page and probably read some of it, my name is Samuel Ramirez. I'm going to be your instructor. I am currently employed with the Corpus Christi Independent School District. My title is Senior Research and Evaluation Analyst, which is basically a person that, in my case, I work with a lot of data. I work with databases. I do a lot of data mining, data warehousing, and we're gonna get into that, all this terminology, so it's not so difficult to follow. My primary job is I work with technology that is called GIS, Geographical Information Systems. I produce maps and demographic information for the school district. In working with that, again, I work with a lot of databases. I get my hands involved all the time on all sorts of information related demographics, databases, export of that information, input of information, so on and so forth. All this ties together because when you are working on information systems, you deal in one way or another with information, with data, single data or multiple sets of data. When you do this, you are involved in almost any aspect of managing information. You don't have to be a database manager. You don't have to be a data warehouse operator or any kind of stuff like that. You can be a person that works at a desk. The mere fact that you're handling data qualifies you in many situations for information systems. Don't ever discount yourselves that your jobs involve one way or another management information systems or a part of an information system. That's what is important. And that's why this course, even though it's a beginning course for a lot of people, it's important to get the basics. It's important to understand where we stand and what we're doing. That way we can tell what is it that we're expecting and what is it that we're looking at. A lot of terminology may be very foreign. It's going to be difficult to follow, but it's not going to be to the point that it cannot be understood. All right. Meet one of your peers in here. Okay. The first, I'm going to jump straight into homework because the first item that I'm going to ask you to do, which should be available now, is I need to do an inventory, or I don't need to do. I would like to do an inventory of your knowledge of computer information systems, of computer applications, of software applications. Many of us are working with tablets, telephones, computers, laptops, mainframes, you name it. Many of us think that we're not involved with it. Unbeknownst to us, we handle a lot of information. We work with a lot of information, whether it's at work or in our private lives. When this happens, then you need to, well, you don't need to. You understand the concept that you can be part of any kind of information system, uh, and that you work with information, regardless of what you're doing with it. Um, let's see. Lost my train of thought. Okay. Now, like I said before, the class and the time. We meet on Wednesdays. On a normal situation, it's be 6 to 10. In this case, because we're a hybrid class, we have uh, a group from San Antonio, we have a group from Corpus Christi. We meet from 6 to 8. My position on the class is as follow. I send you a link for the presentation. I hope you can be participating in the class. I hope you can be here. If for any reason you cannot be here, you cannot participate, or you find yourself still stuck at work, just drop me a text so I know what is happening. What is it going to be with you? Can you make it? Can you not make it? I like to know this. That way we know where we stand with each other, and I know what to look for when I'm having the class in here with all of you. I will finish the class around 8:15. However, even though the Zoom is ended, I'm still available for you. So if you have a question right away, just text me or email me. I'll be responding to emails until I can ready to go to bed. But I will respond to you. If I don't respond to you tonight, I will respond to you tomorrow. But it will be very simple to follow up. The book is called Information Systems for Business and Beyond. This book is the one that is being used for many years. However, this is an upgraded format. It's a 2019 edition. The previous edition, a lot of the links were older and no longer work. Now this will work. I encourage you to read it. It's very simple to read, doesn't have very hard information to follow. So it's not really that boring considering a computer application book, but it's good to follow it. Besides, you are going to be responsible for so much of the class that you need to have to read it. The class, this Zoom meeting is being recorded as we speak. That means at the end of the class, I will post on our Canvas page a video recording and an audio recording of the class. If for any reason you miss the class, you can always go back and review the material that we have in there. So we do that. So With me knowing and with you knowing what's happening, what you're going to have, what your professional applications will be at work and whatever, then you can still follow the class. On a normal online class, you don't have this situation. You don't have an actual person talking to you on a live format. It's usually a pre-recorded format. In this case, we have the capacity of being here and you participating and me providing you the information, so on and so forth. But we're almost, like I said, a hybrid format. We're here and we're also recording and we're also having you participate and be responsible for a great amount of the information. You notice that I said the same thing about 5 different times already. You will be responsible for a lot of the information. And that is because of the short a time that we have on a nightly basis and only 8 classes. Missing one class will put you at a disadvantage. But we can do it. Common course outline is being posted also on the Canvas page. You can read in there the syllabus and the common course. We will follow as much as and as close as we can. If you read the syllabus, you're going to notice that syllabus was made for an actual in classroom class. They are given to us by the administration. So as instructors, we receive the syllabus and they say, this is how you will follow. We vary it a little bit to accommodate the classes and to provide everybody the fastest and easiest way to reach the topics that we cover. That does not mean that we're gonna follow that syllabus letter by letter. The topics covered are pretty much from the book, the chapters and so on and so forth. The information that is provided to you is going to be from the book, from internet research, from research that you will do. I While we have the book, remember this, the book is something to guide you. A lot of the work will depend on yours and your research and your personal professional experience. That's what is so important, that yes, you read it, but at the same time, you take a stake on it and continue to invoke the research that you're going to do. That being said, we will follow what is called APA format. Many of you or some of you have never seen APA. Don't worry about it. This is the time to start learning about APA, American Psychological Association format. If you just got out of a out of not a junior high, but a middle uh, junior college, you probably were following MLA. If you're following MLA, now you're going to switch gears to go into APA. APA, in the true sense of the word, will not be used in here. A business application, a technology application cannot be supported 100% with an APA format, as is truly prescribed by APA. However, if I ask you for a reference on APA format, I'm expecting you to go back and research that format specific for APA. If I will give you a paper to write, which you will have one, and we're going to get into that, the references that you provide to me are going to be labeled references, because references is how APA deals with source material. If you tell me works cited, I'm going to respond to you and say, go back and redo it, because works cited is what MLA does for you when you source information using that format. I am not going to downgrade you or penalize you for APA format usage one way or the other. I'm expecting it. I will review it and I will tell you what I'm expecting and what you need to look for. The whole point is, if you are just beginning your educational career, This is a good jumping point for the rest of your classes where you're going to be doing a lot of writing. In here, you will not be doing a lot of writing. You'll be doing a lot of research, a lot of searches on the internet, a lot of familiarization of data and information, but not in the sense that you're going to sit down and write and write and write. However, if you provide anything to the class or to me that is not your thought, that is being referenced from somebody else, I'm expecting you to tell me, where did you get this information? So source your information as close as you can. You're gonna hear me say, you can do a footnote or you can do a reference page. If you do a footnote, that's a different way to reference your information on APA format, or you can source the information on the paper, and at the end of the paper, you give me the actual reference where that information is coming from. We will work through this. The most important part is to start thinking, if you have no work on APA, how you're going to be working on APA. It's not that difficult, but it's what is going to be expected out of you as you continue your career with the university. And all universities today, that's what they're jumping on. Because we are working with a computer applications class, because we are working with a science class per se, not a true science class, I deal with what is called a technical writer. When you write your paper, when you do your presentation, the write-up that you do is based on technology information and technology writing. So that means to me the following. When you are presenting that paper, you are formatting that paper so your boss, your peers, your team can understand and can follow that paper, because that's what I'm expecting you to be. You are the team manager, you are the team leader, you are the manager, the CFO, or you are presenting to the COO, CFO, whoever. They must understand what they're reading and what they're looking at. But what I'm looking for on the APA format is, how did you do the references for that paper? How did you do the numbering of the pages? How did you do the header? Did you put a header? How did you do a table of contents, a table of tables, a table of charts? That's what we're looking for. So it's not 100% an APA format, but you're going to write the papers and the documentation and apply APA to what you're doing. Okay, enough of that, and we're going to be talking some more about it as we go. Attendance, I'm expecting you to participate. I'm not going to be calling attendance on anybody. I'm not going to call anybody's name in here, because as adults, you know if you are here or not. God knows that you're paying a pretty penny for this class. So it's up to you to participate on the class and make the most of it. You will have the chance to participate. You will have the chance to be part of the class. Homeworks, class participation, and class grading system. The class grading system can be found on the syllabus that will follow. It's based on 100-point assignments and a percentage of the assignments. You see the breakdown of the percentages as you are working with everything. That means that if you miss something and you see a 0 in your grade, that doesn't mean your whole grade is going to go down to a 0. That means you didn't respond to it, so I have to give something. So I give you a 0, fine. But you have 8 different tries to come up and better that 0. Now, 8 different tries of homework means X percentage. That's a percentage of the whole grade. So don't fret it. Yes, it's important. Be participating, be active and proactive on all your assignments. But at the same time, understand the breakdown that you have when you have your grading system. Discussions. There are a series of discussions, one for every week that we have in here. The discussion is going to be available at 6 o'clock of the night of the class. Your discussion results, your participation in the discussion will be due on Monday of the following week at midnight. That means that you have to go in there, view the comment that I made, view the document that I posted or the video, think about the response you're going to give, provide the response, and go read what your peers are talking about. Be nice to each other, respond to each other, engage yourselves in a conversation. That's what we're looking for. The concept of the discussion is not to incite you to be provocative or to be in any way demeaning on anybody. I hope that never happens. The purpose of the discussions from my end is to bring to you topics that are relevant to all of us in this field, in management information systems. And you will see and you will discuss and you will agree and you will disagree. And that is perfectly okay. There is no thing as a wrong answer to any of the questions that I'm providing you with any of the topics of discussion. But I do expect that if you give me a response, it's because you're defending your point of view and your stance on that discussion. That's what I'm looking for. Again, when you look at your Canvas page, you're going to see under the syllabus, you're going to see, and the COOs, you're going to see what the rubric for the discussion is. Are you providing me, sorry about my puppies, are you providing me an informed decision on what you're making? Or are you just giving me a LOL? By the way, I do not accept responses that are written in text format. Write your responses like you're writing to your boss, like you're writing to your COO, like you're writing as a team leader in response to your work that you're doing in a professional organization. The reason for that is because we want you to get used to, if you're not already doing it, that when you respond to a technical document or to a participation document, or in your case, if you're a team leader managing staff and projects, that you provide the correct set of information in the right format. Avoid that kind of information that is causing problems because it's written in such a colloquial way, text format, which doesn't make sense. Emojis, text format, the abbreviation of words and things of that nature are not helpful when you're preparing yourselves for a technical presentation or a presentation of any kind. You can call me old school all you want, but believe me, there is nothing more embarrassing than being in a presentation with your boss and writing LOL or any of the other acronyms, and he's looking at you like, what the H? Why are you writing to me this way? Be professional. So I want you to translate that to you that way. All right. E-commerce, class project, and homework. The first homework for this week, week one, which is already available, is a survey that I'm asking you to complete. There is no wrong answer on that survey. I want to know who you are, your experiences, and your capacity. Nobody is judging anybody. This is for me to know at the end of the semester, at the end of the term, I will have a better idea whether what I provided you made sense or not by just judging your responses on your conversations, on your papers, on everything. Next week, you're going to have for week 2, I'm asking you to produce me a e-commerce class project response. The e-commerce project basically means that you are looking for a company that the primary object of this company is that exists in the internet market and it has a brick and mortar application. E-commerce means that this company is not only selling physically, but it's also selling out there. Now, many of you are going to tell me I want to use Amazon, and that is perfectly fine if you want to use Amazon, because Amazon today has brick and mortar locations. Google, on the other hand, does not have a brick and mortar location, but they're such big companies that they have made an impact. They have made impact on our economy, on the market of management information systems, on the market of technology by itself, that why not? Use them if you can. The paper is asking you from various topics to select companies referring to that topic. So I'm not giving you companies specific, I'm telling you the topic to choose from. Based on that topic, you're going to write your paper and your presentation. At midterm, which is week 4, you will be providing me with a rough draft of your document. Not your presentation, but your document. When you provide the rough draft at midterm, that's 4 weeks into the course, or week 4, you will have enough information already on hand to build your presentation from the skeleton of that document that you created. All you do from week 4 through week 8 is refine the information on the paper and on your presentation. So if you think about it, your presentation mirrors your paper. They're almost identical. If you know very well, a presentation doesn't have everything written on it. You have topics and you address the topics as you see fit in orders of importance. Sometimes the presentation can be done strictly on graphs, because if a graph or a chart addresses everything that you're looking for, you can explain it when you write your paper. We're going to be talking about that, and I'm pretty sure by next week, everybody will have questions about it. But next Tuesday, I hope to have your companies already with me. That's part of your homework for next week. Let me know what company you're picking. And the reason I'm doing it this soon is because remember, with 8 classes, by next week, we only have 6 left, or 2 left before your midterm. So we don't have time to waste. We have to run. We're walking, crawling, and running at the same time, basically, because there is no time to do much. Unfortunately, that's the nature of the beast. Okay. I want to share with you something that is very dear to my heart. And please let me know if you can see this.
The slide rule is one of the coolest and perhaps most important technological instruments that people today have only the dimmest idea what it is.
Yeah.
Great. Excellent.
You know, for example, when you have a screw or something, you can put it in here and then move it, and then you can like measure like how big the head of the screw is.
I'm dying to know what this sliding part is for.
So do you know what this instrument is called?
Absolutely no.
It's supposed to be like a calculator, but I don't know how to use it.
Right around the time MIT moves from Boston to Cambridge, the archetypal instrument, bar none, for the engineer is the slide rule.
Trigonometry, law of sines. No, this is crazy. Sine, radian, tangent, scales. You can do powers of E.
This is what people, went to the moon on. You can see those famous scenes in the movie Apollo 13 where they're all whipping out their slide rules. Well, that isn't for show, that's what they used.
Are you serious?
Wow. Yeah, I think I've heard this.
I have in front of me, though, a large teaching rule, and this would have been in front of the classroom. On the far end are a series of letters. Those are called scales. This centerpiece slides back and forth, hence the name slide rule.
The process of multiplication may be performed by using scales C and D.
Oh, no. 4 is not matching with 8.
I'm still not seeing an 8, and I have like the 1 and the 2 lined up.
This makes no sense.
Could it be that someone actually took it out and flipped it?
Set it to the second too.
Oh, yes, I saw it.
Oh, you are right. It does work. Does it work?
Now it works. Yes, I did the opposite. I matched the 4 with the 8, and then the 1 matched with the 2. It was another 2.
Yeah, it's a lot easier to just do 2 times 4. The poor kids that had to learn this stuff.
When did they stop using these? Not soon enough.
So what happens? Why do they go out of fashion in the mid-70s? Well, not surprising, the digital calculator and computer has a big impact on this.
Would you ever want to replace your calculator with this?
No.
This would be bad.
I mean, it would be interesting to learn to use, but I feel like a calculator is more convenient for day-to-day life.
If you guys were to do your P sets with this, how long do you think it would take?
Oh, it can't do integrals, so it wouldn't be that helpful.
I cannot believe this was like a real thing people used for so long.
All right. Believe it or not, and I'm showing my age now, that was my first calculator. I got to use one of these a while back. The reason I'm bringing this to you is because
today we have a special lesson on the slide rule. The use of the slide rule.
there are many, many, many topics regarding the slide rules. But if you think about it, a slide rule took the man to the moon. So like the movie shows and there, the class shows, it is true what they did over there. So it is a very simple set of technology that we don't think about it because it doesn't have buttons and chips and memory and screen for us to be able to understand that concept. The same as the abacus, thinking of the Chinese format for counting numbers and counting information. It is incredible to see a person operating this, and the same thing with the slide rule. All right, the reason I'm showing you this is because I'm gonna try to show you topics in technology for every class that we have to bring you a different perspective to things also. I'm not going to quiz you. I'm not going to test you on the videos that you're seeing in here. The only time that you're going to be working with a video to answer questions is for the discussions if we're basing the discussion on a video, which is the simplest way and the fastest way to get information going across. All right, let's get into the nitty gritty of things. What is an information system? Information systems are interrelated components working together to collect, process, store, disseminate information. The idea is to support decision making, coordination, control, analysis, visualization in an organization. So, regardless of how small your company or the company that you are working with, or how large, you will be working with an information system. And a lot of people seem to think that an information system has to be a very large piece of equipment or a large piece of software. No, a simple spreadsheet becomes an information system. Because as long as you are collecting data, analyzing processes, store information, disseminate information to support the decision-making process, you are working with an information system. If you go look at the definitions of information systems, the best way to look at information systems is when they focus on components of information systems and roles of information systems. The components of the information systems begin with the hardware and the software. Hardware, tangible physical part of information. You can touch it. All the machinery, all the equipment. Basically, that's what it is. The software. That's when we have instructions designed to provide or act on a process by involving the hardware. So the hardware is reading information that the software is telling it to work with, process, manipulate, so decision making can take place. When you have software, you are looking at operating systems or application software. Let's see if this works. So if you right now on your own computers were to do a search on the internet for a list of operating systems and do a search for application software, I wonder what would you come up with. See if you can do it one search real quick. Do a search for operating systems. See what you come up with. What does the internet tell you right now if you do a search for operating systems? And roughly tell me or post it on the chat, how many are you finding? The same thing with software. We got 12 operating systems so far. Did the loud echo went away? Quite a few. Good, there is no more background noise. We think on operating systems as the one a bunch. Nicole, what is a bunch?
Several. Too many to count.
Too many to count. Did you count more than 10, more than 20?
Yeah, more than 10 easily.
Excellent. What I was going to say is that most of us, when we're talking about operating systems, well, Brittany found 30. When we think of operating systems, we think of what we know. Melanie just found 613. It's about right. Because when we think of operating systems, most of us think on Windows and Apple. That's what we are using every day. Whether we use our phone, our tablet, our laptop, or our computer, we indeed have two operating systems. But if you revert back to 1966, when you start working with operating systems for big mainframes, when you start working with companies that produce individual computers, mainframes, laptops, or desktops for specific applications, they all wrote a set of instructions for that software to work, the operating system. MS-DOS, Adrian, it is an operating system. It's the root behind the original Windows. An operating system today that is used a lot is Linux. A lot of people don't follow Linux because it's so foreign, because it tends to be difficult to use, but it's extremely flexible. If you remember, Melanie just found 667 types of Linux. If you remember using MS-DOS, for those of you that use it, you had to know the code in order to use it. We didn't have the fancy window telling us, go here, go there, do this. You have to know the code. What preceded DOS? It was the operating systems that were working with the mainframes. The operating system working with the mainframes also require you to know the actual command in order to use it. If you go look and start digging today on your computers, on your Windows application computer, if you manage to reach the C prompt on your Windows application, you are looking at a screen based on MS-DOS. Regardless of what we're looking at as a Windows, which means GUI, G-U-I, graphical user interface, you are working with a machine that is giving you a graphic format for you to follow and understand your commands. With the original software, the original operating systems, we didn't have that. We have to write commands for the machine to operate. Now, application software, everything else that we use to make that machine work. But if you think about it, in order for that application software to be existing on a machine, it has to be working with an operating system. The operating system is what let that application software exist on the computer. That's how you know which one is working where. The application software. Do a search for application software. Give me samples of application software. What are you finding with application software? Or anybody tell me about application software? Office, Excel. Very good. Now, Office and Excel, PowerPoint, Dropbox, Word. Excellent. They're all good. They're all right. If you were to put that on a computer, whether it's a Windows computer or a Apple computer, it will work. Even today, you can find adapters to make it work on a Linux machine. However, if you were to put that application software on a machine that has never had an operating system installed on the computer, it will not work. Priscilla, you're talking about Outlook. Outlook is good. Outlook is software application that runs under a suite. Music software like Pandora and Spotify, we're talking a new type of software application that is now going to be based on cloud base, which is the development of the new technologies. Because when you use softwares like this, Pandora and Spotify, you are actually not installing a software application to run in your machine, but you're installing an app, which is a type of application to run under the software. So it almost works like an application software, but it's actually going up higher level because now we're talking cloud. We're talking a different way of looking at the software application. All right. When we are talking about data, there are two items that we need to be concerned with: data and datum. We tend to say data as a general term, meaning anything that is related to information to us. From the technical point of view that you work with, when you work with information, you have to see the relationship of data and datum, because data means information is items that are more than one. It's the plural item of collected information. But if you're looking at a datum, you're looking at a single item of information. Okay? That is important because if you ever start working, or if you are working with databases, with information systems, with database management or database design, you have to understand the relationship of data and datum, because one single piece of data versus a large amount of data or a string of data are two different things, and it will behave different for you. That's what I bring it out in here. Your book doesn't speak about datum per se, it speaks about data, because data is the big picture. And one will argue that one item, 0, is data. A 0 by itself is a number. It also is part of the binary code, zeros and one. 0 in hexadecimal represents something, one item, so it's a datum. But it's data in general because we assume zeros, and now in technology applications, they have a lot of information represented with zeros for you. And it's important for you to understand how you manipulate zeros. So it becomes data for you. So again, yes, you can look at data, and you can look at information, and you can look at datum, and you can look at information. Again, we're concentrating in here on the information related to computers, computer science, computer applications, management information systems. So that being said, this question is gonna come on your midterm. What is data? What is datum? Please don't give me the definition coming out of Webster's for datum and data that doesn't refer to computer science. You must have the application and understanding of what it means based on management information systems, and computer applications. That's what I want to get across to you. All the information we're going to be working with is related to this. A lot of times you find definitions that do not relate to the topic on hand because it's general in nature, it's social science that does not apply to computer applications. So keep that in mind. By the way, the midterm and the final, they're open book test. Your midterm covers the first half of the course, first for week 1, week 2, week 3, week 4, which is 6 chapters, 7 chapters, I believe. And then the second part, which is the final, covers the remaining. Again, it's an open book test. It's not designed to catch you. That is not the purpose of this. When you're at work and your boss asks you for a question and you need an answer, you have your answer because you have your resources available to you. But you have to understand what you're looking for in order to look for that resource. So that's what I'm trying to get to you when you do a test that is an open book test. It's not going to be so difficult that you cannot find it, but critical thinking is important in order to be able to answer your questions correctly. And critical thinking is coming back to the information on data and datum. Because if we're asking you for information related to computer applications, computer science, that's what I'm looking for. That's what I want you to know. And that's what I want to see if you understood. Because if your reference in your response is related to something totally unrelated to data in computer science or computer applications or management information systems, that tells me you didn't understand the concept of data or datum. Okay, enough of that. Networking communication. This is now, it didn't used to be one of the topics that are so important until the advent of the internet. Because communications is everything today on everything that we do, especially with internet on a Wi-Fi format, or if you do it at home with a Wi-Fi or a cellular base or with any other format, it's very important that we understand that communication means that the items that we're using are inter-network. They are networked with something. They're touching something else. Whether it's your single telephone connected to a social app or your computer at home that is connected to the university, you are using a network communication base. That's why it become today one of very important item to understand. Super connectivity, computers, everything depends on communications today because we have so many tasks that are associated with the functions required of us on the computers and the tools that we use. Networking and communications are an integral part to find these responses. Is made of hardware? Yes, because 99% of the time, a network application is related to a piece of hardware. Very seldom you have a true computer application, but it's usually set up to be on a hardware application. They all require connectivity. That function of connectivity is what makes it network communication. We're talking to somebody else, you're talking to somebody else. Another very important, to me, the most important part of the whole process, people. The most important part of the system is human capital. You, your peers, your staff. Without you, the best computer in the world will not work, will not be doing what it wants. Without the programmer, without the analyst, without the database manager, you cannot manage the information that you need. You cannot get the data, you cannot manipulate the data and the datum that you need. Human capital is the most important part of the system. People. That is a question of your midterm also. We're talking about processes. What is a process? Continuous improvement of the business procedures and the integration of technology. So processes basically are steps. Everything that we do in businesses to maintain and continue to do an integration of technology, because the goal is to maintain and to gain competitive advantage over our competitors. Processes is an item that, like data, if you search it anywhere and you get a definition, it's going to give you the wrong definition unless you are focusing on business applications, business procedures, technology, and items that are designed to gain competitive advantage. This is important because in future chapters, we're going to be discussing competitive advantage. Your competition. Who is your competition? Look at your companies, who you work for. Who is your competition? Look within your departments. If two of you have a company with multiple departments, are those departments competing for each other, against each other? Yes, probably so. But the whole purpose of the competition is to gain the competitive advantage over the same company at a different brand. So it's a process, it's a series of steps, it's getting data to work for you through these steps so you can get an integration of technologies and gain competitive advantage. So as you can see, I'm trying to tie everything that we're talking into the respective terminology that we're using, because we're going to be working later on and throughout the rest of the chapters on all the different items that we need to talk about are related to every single step. And you're going to see it. And if you start thinking about it, everything that you do in your respective companies, in your respective jobs, in your respective procedures, even if you are just a student, and I'm not saying just a student in a demeaning format. I'm saying it, if you are not working, but you're a student, you are actually working. You're trying to get a competitive advantage over your competitor. Who is your competitor? Look to the left, look to the right. Who's gonna get the A? Who's gonna be the magna cum laude? Who's gonna be on top of the graduation class? That's your competition. You're trying to get a competitive advantage using the technology tools given to you to gain that competitive advantage. So everybody is touched and everybody sees the same set of information. How you use it, how you manipulate the data, how do you use the network communication is what is going to give you that process to gain that competitive advantage. Using what? Using the people that works with you and works for you, the human capital. Okay. So with the role of information is to take data in and take data out. And then do the transformation of data to make it organizational knowledge. Simply said, you take in, you take out to produce something that you want and that you need. On the same hand, you're going to hear the term, if you don't have already, garbage in, garbage out. That means data that you're taking in with no value being processed by you or your company or your team, producing something of no value, not gaining or not doing anything to gain the transformation of information to realize that knowledge. Garbage in, garbage out, GIGO, GIGO. While it starts as a joke, it's actually a very palpable and present item on our environments today. When we're talking about management information systems, we have to be able to discern the data that actually performs the duty that we want to transform the information and gain that organizational knowledge. Why? Because we want to gain that advantage, that company advantage over somebody. That means your most important tool, your people, have to be properly trained, properly worked, properly instructed to be able to manipulate that data, realize that data, and work with that data. Collect it, transform it, manipulate it, output that information. You need people to either program the computer to do it or they do it themselves. As simple as the person that does the key punch of your invoices. Key punching is taking data in. Where is it going in? It's usually into a database. What is going out? Reports. And what are those reports telling us? Well, that report is transforming information to tell us how much money are we spending on raw materials or on a specific subject or on a specific topic or on a specific part of the system. And we're going to tie all this together when we start talking about the enterprise resource systems, everything that is available in a company. You're going to go back to this about taking data in, taking data out, and doing the transformational knowledge to gain that organizational knowledge in order to gain that organizational advantage. So, a quick chart of where we worked. 1970s, that's when the first mainframes were put together. We're talking about some operating systems, TSOs or MVS. They have some custom application. Then in the 1980s, we have the first PCs or personal computers. And IBM, by the way, was the first one to bring the PC into the market. And they were the first ones to start building DOS. Now, when they built MS-DOS stands for Microsoft DOS. But the IBM products, the IBM PC, had their own DOS version also. A lot of companies began producing their own version of their operating system. Then some of the application software that they built, WordPerfect and Lotus 123. WordPerfect, which is still uses today, is your regular Microsoft Word from a different version of software. Lotus 123, the first business application of a spreadsheet. And it behaved very much like Excel, not as powerful, but back then extremely powerful for what it was. Then we start to see client server, late 80s, early 90s. That's when we put the personal computer and a network together. Some of the first networks, Novell. That's the name of the company that put the first networks together. The first operating systems, Windows for workgroups. That was Microsoft putting stuff for working with the software. That means that piece of hardware, the IBM PC, needed something called Windows for workgroups in order to operate, but it also needed Novell network in order to be able to enhance and produce the communication system that we needed between PCs. And again, you got your software, Microsoft Word, Microsoft Excel, so on and so forth. Then we have the World Wide Web. Then we connect the PC that is connected to a company website, a company intranet. Windows XP, another operating system, Microsoft Office, Internet Explorer. Notice it says World Wide Web. World Wide Web, www, is different to the internet. We tend to associate the two together. They are two different things. You get to the internet by using the World Wide Web. The internet is the pipeline that allows you to navigate the World Wide Web. So we tend to interchangeably use the terminology in here. We say, oh, I'm in the internet. Where are you on the internet? I'm at www.ibm.com. Well, you're on the internet. Well, www is the World Wide Web at IBM, a site on the World Wide Web. But to get to that site and from that site, we need a pipeline, which is the internet. When we did this, Microsoft Windows, which is one of the first ones that came out, produced Windows XP, and it created a reliable connectivity on that intranet. So we have another term in here, internet, intranet. So intranet is communication within. Internet is communication outside that network to get through the World Wide Web. But a company, for example, like Walmart can have an intranet of World Wide Web pages, but they're local. They're only available to Walmart. But to you and me, we can connect to Walmart on the internet at the World Wide Web.walmart.com to see what's available to us, the customer. Web 2.0, the 2000s to the present. They call it Web 2.0 because it's the advent of the laptop and so much capacity for a piece of equipment to connect to the internet using networks that are no longer designed to be connected with a wire, therefore the Wi-Fi. An operating system that became very useful, Windows 7. A lot of you probably remember Windows 7. Again, you have the same kind of connectivity with Microsoft Office, and you have a Firefox, which is a different type of internet browser. You got Internet Explorer. Now today, besides Microsoft Office, you have Firefox, you have Internet Explorer, you have Chrome, you have every software available to connect to the internet, depending on the operating system that you're gonna use. The post-PC, today and beyond. This is an interesting term because it implies that we're no longer using PCs. Well, it turns out to be that doing some research, a lot of people are not using a personal computer, but they're using a tablet, they're using a phone. They no longer need to have a computer with them with a big box to connect to anything. So personal computer itself is being replaced by a sliver of 8.5 by 14 or 10 inches across or 11 inches across or 11 inch or 12 inches across called an electronic tablet, in this case the iPad, using iOS operating system. And this internet application of post-PC main characteristic is mobile friendly. You can visit the same websites that you do on the internet while you're moving. It's extreme mobility. That gave also birth to mobile apps. So the difference will be a regular application that run on a regular website is not as flexible as one that will run on a telephone. That's why it's called an app. It's a mobile app because it's designed for a telephone, it's designed for a tablet. So you get to see it more and more in this way. post-PC today and beyond? Well, a lot of people still use PCs. A lot of people still use tablets. A lot of us use tablets, PCs, and laptops, plus the phone. We are connected everywhere. Anybody has any questions? I have talked for an hour. Nobody has questions. All right, that's good.
Can you hear me?
Yes, ma'am.
Hi, are you going to be emailing these slides or making them available to us on Canvas?
Yep, they will be
Okay.
available on Canvas also.
Okay,
Every
thank you.
presentation with the recording.
Thank you.
Yes, Melanie. All right. So, can information systems bring competitive advantage? If we understand the term competitive advantage, that means getting ahead, doing better, getting bigger. That's what competitive advantage is. So can an information system provide that to you? Back in 2003, a gentleman, Nicholas Carr, wrote an article that questioned this assumption. And he called it IT doesn't matter. He stated that information technology was just a commodity. Technology was not an investment that will make a company stand out. It should be seen something like electricity. It should be managed to reduce cost, ensure that it's always running, and be as risk-free as possible. So IT doesn't matter. If you think about it, information systems are so important to our companies, to our businesses today, that we have to make sure that they're up and running, producing optimal response in order for us to be able to function. Thus, it's a commodity. You need electricity in order to work. I says, well, I don't need electricity. I can put a generator and I can still work. Yes, you can still work with a generator. However, the flow of electricity from a generator is not as good and pure as regular flow from the electrical lines. So reliability of your business is going to depend very seriously on how accurate and how good is that electricity. Well, the same thing is happening to technology today. We depend so much on it for everything that we do. Our companies depend so much on it that if they wouldn't have it, they don't have a competitive advantage over their nearest competition or their strongest competitors. They need to be always running, and as we've seen today, need to be risk-free. If they're not, you run into problems with that. We bring Walmart in here because Walmart is become one of the leading lights on information systems. Everybody knows Walmart is one of the largest retailers in the world. Their systems are so fine-tuned that they can see on a given moment how much inventory they have across every one of their stores and how much inventory they have available to transport from their manufacturers. Their manufacturer can respond to a shortage or a production need within hours of being informed of it. Now, you will say, well, that is not true because remember what happened with the pandemic? We all ran out of toilet paper. We all ran out of soap. We all ran out of cleaning supplies. Well, that is the most extreme case and one of the most interesting cases. Even if we wanted to have the toilet paper, we couldn't, because nobody in China was working, because they were all sick too. So the system failed. Why? Who did I say is the most important part of the system? People. Without people, I don't care what kind of system you have, you cannot maintain it. As automated as it was, you still need the boot on the ground to load the raw material onto that conveyor belt and start producing the roll of toilet paper, the bar of soap, or the cleaning supplies. So even if Walmart ran out, because they had a run on their warehouses and run on their stores, information was already available in China before the last roll came out of the store. But guess what? China could not produce fast enough. Everybody was sick. And even if they were able to produce like they started to produce, nobody could ship, because a single boat was not available to bring anything in country. The transportation system, the supply system was down. So the pandemic has bring a very important thing to any information system that is available today in the market. And everybody today is doing a study of how they can mitigate and how they can resolve this problem. If you think about when, with the advent of Walmart and their inventory systems, and you probably have noticed it if you ever look in the back of an HEB or the back of a Walmart, there is hardly any storage capacity or stock in their store, because they don't have to wait to stock up shelves, because they have trucks coming in every other day, and they can keep enough stock on the shelf to move to the shelves and to the from the back room within hours. Before, it used to be that the manufacturer had to have actual storage of inventory in warehouses built in the stores. What does that mean to the company? The store like HEB, like Walmart, had to pay for product to be stored. That's a cost that will affect their bottom line. The manufacturer had to produce based on projections what they will need to stock across all their stores that they supply. So if you think about it, the old supply system, the old enterprise management system, rely on you stocking and storing inventories. The new management information systems, the enterprise resource management systems that we have today, allow you to respond to an issue within hours. Therefore, you don't have to maintain that kind of information, that kind of material on hand. You can do it within hours. As customers, we were the first ones to feel the shortage, because we didn't have what our needs were asking. Walmart was feeling the pinch because economically could not sell. HEB could not sell. Their warehouses were empty. The illness shut down transportation. You couldn't bring, even if you had it in warehouses. The warehouses in China could not move because you did not have enough materials to work with and people to get it to work for you. So this competitive advantage has turned a new window thanks to COVID-19. Information system is become a commodity. We need to have it. We need to be up to the point that that technology is 100% reliable in order for the company to be competitive and to subsist. But now we're dealing with totally different forces that we were not dealing with before. We're going to hardware now. So what is hardware? Hardware are the physical items, the pieces. The digital device is a different kind of device. It's part of the actual physical device, but is enable us to bring information at a faster rate than we used to do before. As I said before, computers work with the binary systems, twos, ones, and zeros. Every one or a zero is 1 bit of information. A group of 8 bits is become a byte. And you hear all this terminology all the time because when you're looking at your computers, when you're looking at everything, you're looking at this kind of information. Computer manipulates information based on 8 bits of information at once. So look at it this way. If all the information is converted to sections of bytes of 8 pieces at a time by using bits, zeros and ones, you move blocks of 8 bits at one time. Now, the advent of computers is allows this to change to 64 bits of data at one time. Thus the term 64-bit processor. What is changing is what is happening with processors today. Processors are allowing us to maintain faster and more capacity with our computers. The 64-bit processor is expanding now to more capacity on that little piece of hardware that allow us to manipulate information. So when you look at binary prefixes, you're looking at what is a byte, a megabyte, a gigabyte, a terabyte, a petabyte. It's all on multiples of 1,000. From megabyte forward, you're working in multiples of 1,000. When you're talking about items like this, to manage, manipulate, and store information, it also implies that that processor can manipulate that binary code fast enough for it to be okay, it be worthwhile for us. You must have memory to enable the computer to work for you, and you have a way to store that information. Well, storage, hard drives, now has changed because now we're talking one more realm. Now we're talking clouds. So things are moving out from our physical location into the cloud location. So the digital world is expanding. So we're talking about other computing devices, portable computers, laptops, tablets, smartphones. We talk about the rise of mobile computing because a smartphone is basically a computer. It's allowing us to do a lot of the work that we used to do on a personal computer. Now, there are some tasks that cannot be done on a phone. First of all, size, but speed-wise, it can handle it. but certain amount of graphics and certain amount of size on the document that we work with cannot be used. So you end up working with the next step up, which is your tablet or your laptop or your personal computer. But because of Wi-Fi and networking that is of this nature, now everything is mobile. Thus, the rise of mobile computing. We're moving out of one single location and we're moving into a durable, portable format in which you can handle data and you work with data on a constant basis. The next step that we're talking about is integrated computing. We're seeing this, the most common right now is the self-driving car. We have companies that have been able to do programming so a car can drive by itself, which is incredible. Or the smart house, where you have a computer application or a web application or a cloud system managing everything you do in the house. Your refrigerator is connected to the internet. You can see inside the refrigerator. It can order for you. You can have a washing machine that lets you connect to the internet, and it can also control your energy usage. It control your cycle. It control your heat. So all this integrated computing that we used to think of only the house, only the computer, only the box that we call the personal computer, only the box that we call the tablet or the portable laptop was the integrated computing. Not anymore. Integrated computing is applicable to everything that we have on our society today. That's why the last item that we're talking in here, the commoditization of the personal computer, means that we are not talking of computers as items that are just put them in there in a box on top of a desk, fire and forget. You don't use them anymore. No, computers are a commodity today. The faster they run, the faster you access information. The faster they run, the more capacity they have to process, the faster you're going to have an output. The faster you can model something, the better the results are going to be for you. The computers have changed the way we do business, not only at home, but our independent business, our actual business themselves. We depend on them 100%. And how much we try to gain a competitive advantage over our peers or our competition will depend exclusively on how much computing capacity we have. This is one of the things that you're going to see the most common affecting decision making on your buildings, on your staff, on your companies. When the computer is part of a commodity, that means networks, hardware, and software continue to be upgraded all the time because the latest sometimes provide to you the capacity to gain that competitive advantage. Now, you look at a small business, I will say a small mom and pop store, where they have a small inventory system, they can still use the same Windows 7 application to run everything in the small business. That's fine. The problem comes in when Microsoft says at the end of 2020, we will no longer support Windows 7. You say, fine, don't support it anymore. Well, you're not thinking yet, because if something goes wrong with Windows 7, now you're going to have to find somebody else to help you with Windows 7, because Microsoft will no longer support your Windows 7. Now they want to support a higher level of application. So that application, the commodity that you call the computer today, gives you a competitive advantage on your business. That's what is becoming so important. It's no longer a tool, a box, a piece of hardware. Now it's integral part of your productivity and your capacity to gain on your competition. We were talking about this earlier. Bytes 1024. Again, we're talking about base 2, numbering system. And there's the description. Kilo, 1000 mega, million, giga, tera, peta, exa, zeta, yoda. Never seen a yoda. Never seen a zeta. Never seen an exa. And never seen a peta. I own a couple of teras. But when you're talking about items like peta, tera, exa, zeta, yoda, you're talking computing to the highest level. Something that requires so much computer time, such a fast speed, that you need to do uh, access to this kind of capacity. Uses usually hard drive capacity in digital format or in actual drum or uh, physical capacity that they have out there. Most of the computer that is online now, mobile online systems and cloud systems are using the peta, exa, zeta, and yoda because they're no longer working for one person. They work for multiple companies, multiple people. That's why you run into this kind of situation. The computer components, you look at a box, and this is the main stuff that you have in the box. The CPU, the central processing unit, the motherboard, the RAM, the hard disk. These are the main components that make your computer. Whether it's a phone, a tablet, or an actual box, you still need this in order to operate that system. The main component of the computer is your motherboard. Whatever you do, you still need this piece of equipment in order to work. This is where you connect different things, your USBs, your network, the old mouse, old keyboard application. This is an old keyboard. This is the slots where you put the different cards that come in there. Memory, this is where you put it on. This is the processor, the central processor unit. A battery for your clock, and different switches and poles throughout the motherboard. All this come into practice because it's all needed for it to connect. So remember when we were talking about hardware, this is one of the main components. This is the main component. Whether it's a telephone, a laptop, or a tablet, it requires something like this in a different configuration. Then you have processors. The motherboard is the main component of the computer. The processor is your brain. What is the brain of the computer? Each one of these little round things in here, these are transistors, and they are in the millions. So every one of these items in here are going to be the cores that the processor has. So this is the maximum, 10 cores. Bottom line, this is the brain. This is what makes the machine work. This is what that motherboard requires in order to be operated on. I'm showing you two types of processors in here, Intel and AMD. We're going to be talking about this because the market is basically set up so only two people operate on processors today. Lyndon, like Alienware. Alienware is actually a hardware configuration. It requires the motherboard, and it may have by itself items already included on it, or it could be a motherboard by itself. So you are correct. Motherboards have evolved like everything else. If you think about it, a motherboard is the most important part of the computer. If the motherboard evolves to allow faster and better add-ons to put together on it, that computer will allow to run faster. If the motherboard has the capacity to put an AMD Ryzen or an Intel Core i7, which is the fastest processors in the market today, you will be able to run a very good application on it. But the motherboard has to be able to support it, otherwise it will not work. So the motherboard is the main part of the computer. It requires something like this to run. Like everything else, the motherboard capacity will enable the processor capacity to function at its best or not. These are the other components that you have on the computer. You have memory, the sticks of memory. And you hear this term a lot because how much memory did you have? Oh, I got a couple of gigabytes. Oh, a couple of megabytes. This is all the information is stored on items like this. It's not actually stored, it's passed through this, which in turn is piped through a pipeline in the motherboard that is called the bus, and it moves the information back and forth using these memory chips, and then it goes onto the hard disk. A hard disk is just a disk with a spindle, and the spindle has different ways to access that information in here. It goes from left to right or from right to left, and it writes on the top and it writes on the bottom. That is one type of hard drive. The newest type of hard drive is what they call the solid state drive, which is basically a chip. One of these is basically this, but it's designed so it runs very fast. It's faster than something like this. If you think about it, these are based on revolutions per second. This no longer accesses revolutions per second because it's no longer turning. It doesn't have to turn to store data. It evolves the data directly onto the chip, and that's how it stores the information for you. Video cards. Video cards used to be just an item that you add to a machine, a motherboard, so you can connect a monitor and view the information. Nowadays, video cards are like almost motherboards on themselves. They have memory, they have processors, they have speed, they have fans, they have everything. Because what the evolvement of the processor is that the processor will allow the video card to function independently, so it doesn't take resources away from the motherboard. So your application is going to run faster if it's very graphic intensive. Lindell was bringing something about Alienware. Alienware is a typical motherboard for gaming, and is extremely fast and is extremely functional if you were to have an SSD drive with a video card like this, like a GPU, where multiple multiple monitor formats with its own cooling system and its own memory system on it. When it processes the graphic information that it's supposed to handle, it no longer has to depend on going to the actual memory chip to perform that operation. It processes internally here and it projects to the monitor directly. The motherboard, the video, the hard drive, and the memory are providing the instructions needed to transform the information onto the video card. Motherboards have evolved, hard drives have evolved, graphic user interfaces have evolved, the GPUs, the graphic processing units, have evolved to the point that people are trying to gain advantage, that operational advantage over everything. That's why you see everything evolving. So when we say that the PC world is no longer there, it actually is there. It's not as present anymore in the way it used to be because not everybody is using a PC. Not everybody goes and build a PC. Not everybody goes and work on pulled in solid drives or memory or processors to manage information unless you're directly involved with a specific set of tasks to manage that information and to work with that information. Most of us that work with a laptop, with a telephone, or with a tablet, we're not interested on this kind of graphic interfaces or this kind of memory interfaces, even though Apple has revolutionized the market with their graphics in their tablets. They are so good and so accurate because their screens are better than most monitors today because of the refresh rate and all the different utilities that they have available for their tablet. So they have invested that money on the graphic unit, which is the monitor, because it's built in all together into the same unit. Their processor is fast, but they're designed for consumption. It's a commodity for you and I to work on everything that we're doing. All right. We have now network interface cards or NICs. Anything you connect to a network is a network interface card, whether it's hardwire, Cat5, Cat6, or a wireless system. This is a wireless system. This is a wireless system. As long as that exists, it's a network card. This is a network card. This is a network interface card. This is a wireless network interface card. It's usually put on a laptop or a actual desktop machine or a PC. This is something that you can put on a laptop or a regular computer and it will work the same way. The network interface card is producing the network connectivity that we were talking about earlier. So as you can see, we're tying everything together in here now as far as everything is needed for the reflection of all the applications that you have available when you're talking about information systems. Okay. In 1965, Gordon Moore did some research and say how many transistors can be put on a processor. And then he made the discovery that basically technology was moving so fast that every 2 years the capacity of the processors was doubling the capacity of the processors. So if you look at this chart from 1971 to 2016, in 2016 you find processors that were managing to have capacity of 20 million transistors in a processor, and so on and so forth. So Moore's law is very common today to identify this kind of information because the idea is or has been that processors are evolving so fast that we are changing every 2 years. Well, that has changed already. Technology is moving so fast that now is even the conversation that technology is moving as fast as every 6 months. Every 6 months, we are making changes in our technology to the point that we're evolving and we are changing. Because of the changes that are happening on Moore's Law, physically, there is no more capacity available on a processor. As you can see, a processor is just a wafer, a piece of a resin coated with gold and solder, and transistors are built into it. There is only a finite capacity on the number of processors you can put, transistors that you can put on a piece of metal or a wafer. That's why the trend today is to say that Moore's law is dead. I mentioned to you before the graphic processing units, GPUs, or your video cards. Video cards are evolving so fast that video cards are having now capacity built in into their own systems to outspeed and outdo an actual processor. So when Huang, who is the president and CEO of NVIDIA, NVIDIA is the company that makes a lot of the video cards in the market today, which are very good applications, very good tools. He says that Moore's law is dead because of the limitations. Circuits cannot be reduced any further. You cannot put any more stuff into a circuit. But graphic processors units are increasing faster than GPUs, than processors. So the controversy has erupted in which one is the true statement today, Moore's law or Huang's law. Depends on who you see, depends on what you read, depending on the application that you're using, you're gonna see both of them are alive. You can have multiple processors put into an operating system like a mainframe that has the capacity for multiple operating systems in order to work large amounts of data. So if you put 5 or 6 or 10 processors, each one of them with 20 million transistors in it, the fastest you can put, and enough hard drive space, you can still process information very fast. But if you are relying on that information to be visualized, you want to see, or the information is supposed to be produced to you in a graphic manner, that's where the GPU capacity comes into place. The processor will never have enough capacity to keep up with it. Where is this apparent? With the new technologies today on simulations. The US Navy can build today an aircraft carrier nuclear plant by using a totally simulated nuclear reactor, which is a graphic user interface that projects onto a room, and the technicians can actually work and design on site, on the spot, using the computer application, the best capacity for that nuclear reactor. The processors themselves, Moore's law, will do the crunching of the numbers. Yes, no, yes, no. But having the fidelity to be able to see that information in such a high quality as that format that you're getting to see when they do the actual projection, the actual simulation, will depend strictly on that graphic processing unit. No processor can handle everything by itself. No graphic processing unit can handle everything by themselves. It needs both of them. But the evolving of technology is enabling us to do this kind of information today. Computing devices, more portable computers, smartphone, and tablet computers. This has given birth, if you may, to what is called the Internet of Things, or IoT. Like it says in here, millions of devices that are put together to work on an own network addresses around the world, allowing them to connect to the internet for the purpose of collecting and sharing data without the involvement of human beings. Think about it. Without the involvement of human beings, you're actually allowing systems to produce information for you, to handle information, to gain a competitive advantage on something. I give you the best example that I know of, that is for the geek in some of us, the extraterrestrial research program, SETI, SETI, that is being run out of a multitude of colleges. They put a signal into a space for radio telescopes. There is not enough computing capacity to crunch all the numbers, to put all the power and put the signal in one single computer. So what they have done is, if you sign up for SETI or Yeti, I have to go back and I'll get back on this on you to give you the correct terminology. But the whole idea is all of them have gotten together and collecting computer power, so they can project the signal that they want further and further. And also to analyze the data that comes back, because one single computer cannot analyze all this data. This is the Internet of Things. When everything is being put to work without getting people involved, and you're using the tools to work for you. We talked about this earlier. What is the commodity of the personal computer? The commoditization of the personal computer. We're no longer a technical marvel. Now we're a need. We need to have it in order to work. Everyday life is being affected. There are no difference sometimes in companies. Without the computer, you need them for determining profit margins. And having computers themselves is not producing a profit margin for you. You need the computers and the processes in order to gain the competitive advantage and actually gain that capacity to produce better and better results. This is why it's a commodity, because we have to depend on them in order to produce what we want, in order to gain what we want. All this has created a problem. The more computers we use, the more problems we're going to run into. Because we are a society of consumption. And full disclosure, this is not a political statement, and I'm not giving anybody political information or anything like that. I'm just bringing up a fact because you're reading it today every time you read a major newspaper or major website. The amount of pollution being caused by the electronic waste. Since we like to buy so much, we are not recycling what we have. When we don't recycle, we just continue to put away and throw away equipment. That equipment that we throw away is being taken away and piled up. It's trash, but it's the worst kind of trash because we use all sorts of chemicals and all sorts of materials to produce all the electronics that we have. These are poisons. And we don't take advantage of everything that we have, but we're getting somebody else to do the work for us of maintaining and cleaning this equipment. As a society, we have to be more careful with this. And you're going to see later on, this is one of the items that we talk about in one of the discussion sites that we have. The problem with electronic waste, because we have to take a stock on this. We have to stop and find better ways to produce and to recycle what we have. Guys, that's all I have. It's been a long 2 hours for all of you. I can see you. All of you have been working all day, have been in classes, have been dragging. I'm surprised I don't see coffee running around. But anyway, I appreciate you sticking around. I hope that we can get a good class going. We got good topics to discuss. Every week we're going to have something different. Go through the Canvas page, start looking at your homework, start looking at your discussion. If you have any questions, just text me, call me, and let me know what you need. Melanie, what do you need? Somebody was raising their hand. Okay. Everybody have a good night. I'll be hanging around in the house for a little while longer. If you have any questions, just pipe them up, email me, or text me.
Can you hear me now?
Yes, ma'am.
Okay, I am so sorry I was talking. I didn't realize you couldn't hear me. On the homework assignment, when I clicked it earlier, nothing pops up. It says do the inventory survey. So when you click that, it says this form is currently not accepting responses. Create my own form.
Oh, man.
So then at the bottom, I hit text entry. It's a start entry, attempt 1, and I hope I didn't mess anything up, but then I hit delete.
Okay. I'll go back and work on that right away. Thank you, Priscilla. I will work on that. Remember, this is not something that is going to be too difficult for anyone because it's an inventory. So let me work on it right away, and I repost it so everybody can see it and everybody can complete it.
Okay, thank you. This was Melanie. Thank you so
Yes,
much,
ma'am.
sir.
Thank you, Melanie. Priscilla also did tell me the same thing, that hers didn't work. So definitely a problem with the form. All right, no problem. We get you squared away so everybody can answer the form and can respond to everything that we need.
And
Okay.
then one more question for the discussion. It
Yes.
says .au. So is that an Australian website? Because my security in Norton clicked all kinds of buttons and stuff. It's okay to click.
Oh, it's
on the week 1 discussion. It says click a short video from Network Australia.
Let me see. Let's see, week 1 discussion. Yes.
When I clicked,
Well, what it is,
mhm.
the first part is 11 Network Australia's a newspaper, but below is the YouTube link, the evolution of Boston Dynamics. That's a
Okay.
YouTube video.
Okay, but when we clicked the article, that's what was throwing off my
Right.
internet
It
security.
goes
Okay.
to a website in Australia because that's who published the original item on evolution of Boston Dynamics. If you go to the YouTube video by itself, it doesn't take you to Australia. It takes you to a YouTube video.
Okay, thank you.
All right. Great questions. Anybody else? Comments? All right. So like I said, I'm going to stop recording and I'm going to post the recording, video and audio. That way everybody has access to it. And I will work on this, fixing this inventory for you. So that way you can take care of it. All right. Thank you, everyone. Have a great night.
Thank
Have a great night, Professor.
Thank you.